I want to start off by giving you guys a rundown of all the parts I used for this build. To start, I went with the HQ 4045 bullnose props. Sorry, not the 5045s. Some 10mm nylon standoffs, male to female, as well as some 30mm nylon standoffs. This will be for the middle top plate of the frame to protect the flight controller. Some 20mm nylon standoffs to protect the flight cam. Get a bunch of 6mm nylon screws, as well as some 10mm nylon screws. And then you're going to want to get a bunch of M3 nylon hex lock nuts. I also got some orange braided mesh, which I haven't put on the quad yet, but I'm planning to. All of these parts I got from multirotormania.com. They're based up in Sacramento, California. For the powertrain, I'm using the DYS SN20 BL Heli flashed ESCs. For the motors, I'm using the T-Motor 1806 2300 kV. For batteries, I'm going to be using a combination of Nanotech 850 mAh to 1000 mAh 45 to 90C 3S. My frame also can handle all the way up to 1800 mAh batteries, which I tested already. For the power board, I'm using the Multirotor Mania power distribution board. And for the frame, I'm using the Armattan 180 one-piece frame. Got the Naze 32 flight controller and some ready-made RC addressable LED strips on the rear. For my radio receiver, I'm using the FreeSky X4R. I would recommend getting the D4R2 if you can find it in stock somewhere, because I had to use a S-Bus to CPPM converter for that. For the camera, I'm using the Amway CMOS 600 FPV cam, and I have the Pololu 5-volt step-down, which is going to power my Naze. For the Video TX, I'm using the Hawkeye 200mW Video TX, which has performed very well in my tests so far. So the first step is to remove the motor wires coming off of your ESC so we can directly solder the motor wires to the ESCs. So to prep your motors, you're going to want to strip off about a 2mm portion to expose the wire. Once you've done this, you're going to want to pre-tin the motor wires. After you've done this, simply connect the motor wires straight onto the ESC pads. Two motors should be sequential, and two motors should have two of the wires reversed. So this is like my first kind of true build video, and my head's going to get in the way for some of these shots. I didn't have the best camera setup. Hopefully next time I can get an actual mount to put my phone on. But if you guys miss anything you can't see, just leave a comment below, and I'll get back to you ASAP with an answer. Now that you have your motors wired up to the ESCs, I'd recommend mounting the motors to the frame to make the installation easier to the power distribution board. Alright, so the next step is going to be to measure out your power and ground wires coming off of your ESCs. Once you have them measured properly, go ahead and cut them to length and then pre-tin the tips. Now what you're going to do is connect the red to the positive on the power board and the black to the negative on the power board. Just make sure you pre-tin the power board with a nice dollop of solder. It doesn't really matter where you place the positive and negative around the board. Just do whatever helps you make the cleanest build possible. So for my battery connection, I decided to tuck the positive and negative through the two slots on the bottom of the board because I'm going to be placing my battery underneath the frame, which I find helps with the center of gravity for rolling and flips. Something I always like to do on any solder points is throw some liquid electrical tape onto the connections just to protect it from any moisture and to avoid any wires accidentally touching the board and shorting out your quad. I decided to go with the XT60 connectors because most of the batteries I buy have this connection. What you're going to want to do is put a nice dollop of solder onto the copper pins coming out of the XT60 female connector. Then pre-tin the tips of your positive and negative wires coming off the power distribution board. Just make sure you have enough slack to reach the battery. Before you solder on the connections, make sure to throw on some heat shrink so you can protect the connections. Once you've done this, I recommend zip tying the wires down to prevent the cables ripping off during a crash. Now at this step I decided to throw on my NACE 32 just to see how everything fits. I actually ended up mounting my board upside down to tuck the wires in for a cleaner build. If you guys see my videos before, you know I really like LEDs on my quad. It helps for visibility when racing and it also looks really cool when up in the air. For the front of my quad, I'm using the Ready-Made RC white LED strip, which comes with 5 LEDs. So just find some wire that you have laying around from an ESC, and you're going to want to solder the red to the positive, the black to the negative, and then throw on the double-sided tape that comes with the lights. I tried putting this on the rear, but it didn't really fit, so I decided to put it on the front arms. Now just make sure that you have enough slack on the cables to come to the power distribution board and clip where needed. Then remove a portion of the tip and pre-solder the tips. Run them through the frame and go ahead and solder them onto any positive and negative on the power distribution board. Alright, so the way that we wired these LEDs, when you power up the quad, the light's going to be on all the time whenever the battery's connected. There's other ways you can hook up LEDs using a turn-energy on-off switch, which you can program into your Tyrannus, so you can have your lights on or off at the push of a button. But I figure when my battery's plugged in, I'm usually flying, so I want the lights on at all times. For the rear of the quad, I'm using the addressable LEDs from Ready Made RC. So to power these, what you do is solder the positive and negative wires onto an empty pin on your flight controller. See here, the red goes to positive, the black goes to negative. You can just solder these directly onto the board. And then going to the addressable LED strip, do the same thing, you just solder these directly onto the positive and negative. And then for the signal wire, you're going to connect that to the D-in on the LED bar. And on the flight controller, you're going to solder that directly onto pin 5. You can see in this picture here, the power going to the LED strip, I actually soldered it in the wrong position, covering the mounting slot for the flight controller. So just make sure you have room to fit the screw in on the 10mm female to male mounting stand opposite the flight controller. So when you first power up the addressable LEDs, there'll be a default setting for all the lights. What you're going to need to do is go into Clean Flight and program each individual LED to perform the way you'd like it to. Alright, so let's go into the Clean Flight setup and just go to Other Features and check the box next to LED strip and click Save, and then we're going to move on to the LED tab. Alright, so to program these LEDs, go into the Clean Flight Configurator LED strip tab. To start off, click on the wire ordering mode, and then starting from right to left, click the squares until you hit 7. This will mean that you have 8 LEDs total, starting with 0 to 7. Unselect wire ordering mode, and then go ahead and click on 0. We're going to make the right LED an indicator, as well as a color. We're going to choose purple for this one, but you can do whatever color you'd like. This means that when the quad is going straight ahead, it'll be purple. When you turn right, the indicator will flash yellow. We're going to do the same for LED 1, indicator, and then select color and purple. For the middle 4 LEDs, I decided to go with arm state. And then also I selected color of purple. My idea was that when the quad is going forward, all LEDs will be the same color, increasing its visibility during a race. When the quad is disarmed, the middle 4 LEDs will be the default green. When it is armed, all 4 middle LEDs will be purple, as well as the 2 outer indicator LEDs. So for 6 and 7, these will be the left indicators. We're going to select indicator, then color, purple. Do the same for 7. And then go ahead and click Save. Alright, so here's what the LED should look like now. This is disarm state with the middle 4 being green. This is a right turn with the yellow flashing LEDs. Left turn here with the yellow flashing LEDs. And then when you arm the quad, the middle 4 are going to turn to purple. Disarmed, middle 4 go back to green. Right turn. Pitch backwards. Left turn again. And then one more time, this is what it should look like when it's armed. Now moving on to the flight controller. As I mentioned before, I'm using a Pololu 5V step down to power the flight controller. For this you're going to need two 90-degree angle pin headers. What you're going to want to do is solder the pins to the V out and the ground on the Pololu step down. The reason we need this Pololu 5-volt step down is because the power coming off of your distribution board is 12 volts, while most flight controllers require a 5-volt to power them. There are some flight controllers that have a converter built in, like the Dodo, but they run a little more expensive, like $55. You can also use a UBEC to power the flight controller, but these take up a little more space. They are easier to install, but I like the Pololu because it's a little bit smaller. Once you're done, it should look something like this, with the ground and the V out both having pins soldered to them. Alright, so to power the Pololu, we're going to run it directly off of the power distribution board. Pick any open positive and negative port. You're going to want to solder two 90-degree pin headers to the positive and negative. The short ends of the pin headers should be sticking up and the long end should be soldered straight to the board. Once you're done, it should look something like this, with the two pins coming off the power distribution board. So what you're going to want to do next is solder the two pins coming off the power distribution board onto the Pololu 5-volt step down. Now in this clip I have the pins on the Pololu facing out, but I actually ended up reversing it and having the pins facing in, which you'll see in the next picture here. Alright, so once you're done, it should look something like this. The two pins coming off the power distribution board are just soldered onto the bottom of what you see here, where the 90-degree pins are coming off the Pololu. Alright, so the pin header that you just plugged into the Pololu step down, you're going to take that and plug it into two 90-degree pin headers sticking out of port 5 on the flight controller. Ground should be on top and then positive should be on bottom, as you can see here in the picture. So for the ESC pin headers on the flight controller, I'd recommend using 90-degree pins facing inwards. This will allow for a much cleaner build in the end. You're going to want to solder 90-degree angle pins onto ports 1 through 4, as seen here. So now it's time to wire up the ESCs to the flight controller. The front of my quad is facing the bottom of the screen. So the back right motor is going to be going to the top pin on the flight controller. The second motor is the front right, which will go to port 2 on the flight controller. The third motor you want to connect is going to be the back left, and the fourth motor that you're going to want to connect is going to be the front left. Alright, so now that you have your ESCs wired up, it's time to power the board. So you're going to plug in a 2-pin header. What I did is I just clipped an old ESC header so that it only had 2 pins. And then you're going to plug that in to the two 90-degree pin headers coming off of the Pololu. So this is a handy diagram showing you which motors connect to where on the NACE 32. Remember, for this build we're going to be mounting the board upside down, so just keep that in mind and look at the numbering on the board when plugging in the motor ESC wires. Alright, so here are my PID settings. I'm using the Multi-Wii 2.3. For my roll and pitch rate, I have it set to 0.7, and my yaw rate is at 0.6. These are a little aggressive, so if you're new to flying, I'd recommend starting at 0.1 or 0.2 and then moving it up as you feel more comfortable. These basically reflect how fast the quad will do a roll or do a front flip or back flip. Alright, for the ESC/motor features, we're going to check motor stop as well as one shot because the DYS 20 amps are one shot enabled. This basically allows for a faster signal connection between the ESCs and the motors. Alright, lastly for the receiver mode, you're going to select RX PPM enabled, and for the serial receiver provider, the Spectrum 1024. Alright, for the receiver, I would recommend the FreeSky D4R2 CPPM. It's $22 from Loft Hobbies. I actually had an X4R laying around that I wanted to use for this build, but that requires an S-Bus to CPPM converter, which is an extra $13. So if you have the D4R2, you can ignore the next steps, but if you have the X4R that you want to use, please follow these next steps for connecting the S-Bus to CPPM, which is pretty easy. So here's the X4R. It's about the same price as the D4R2, but it runs the S-Bus. And this is the S-Bus to CPPM converter. Alright, so let's start off by measuring the length of the wiring going from the X4R to the S-Bus to CPPM converter. Once you have it all measured out, just go ahead and clip the wires and then strip off the ends so we can pre-solder the tips. So just find 3 loose wires you have laying around, a positive, a ground, and a signal wire. Any wires will do. For my build, I actually cut them to about 1.5 inches to 2 inches. Then you're just going to solder these on to the CPPM converter. So this wire you see here is the ESC plug that I'm going to be using to connect to the X4R. I'm actually going to just solder the other end of the ESC pin header directly to the S-Bus to CPPM converter. Again, just measure it out, snip off the ends, and then pre-solder the tips, and then you're going to just solder it directly to the converter. So signal is going to go on the top. Make sure you have solder on the board as well. Signal on top, power in the middle, and then ground is going to go on the bottommost pin header on the converter. So once you have the ESC plug soldered to the converter, you're going to want to solder the other end with the exposed wires directly to the flight controller board. Sorry, my head kind of got in the way here. In the next clip I'll show you exactly where you're going to solder these pins to. This is what it looks like when it's all connected. So I'd also recommend just throwing some liquid electrical tape onto the converter. Just go ahead and cover it all up just to protect it from touching any exposed metal on the quad. So here's what it looks like coming from the converter to the flight controller. You're going to have signal on the top, power in the middle, and ground on the bottom. Signal is going to go to pin 1, power is going to go to the circle symbol, and then ground is going to go to the header that doesn't have any symbol or number on it. So to help you visualize what we just did here, we took the converter and the S-Bus input connected to the receiver with the CPPM output connected to the flight controller. And here's what it looks like on my rig. I used some double-sided foam pads to mount the X4R on top of the flight controller in between the top plate, and tucked the converter behind the FPV cam underneath the front plate. Alright, so now it's time to bind the receiver to the radio. So go into your model setup, go all the way down to the bind section. Also note that you want to have your radio in D16 mode with a channel range of 1 to 8. Okay, so once you have that all ready to go, what you're going to need to do is hold down the bind button on the X4R, which you see here, while you're powering the quad on. So you might need someone to help you. I was able to do this myself, but it's a little tricky. So go ahead and hold it, power it on, and then hit enter on your radio while you're hovering over the bind button. Just hold it for a second and then go ahead and power down your quad, hit enter on the bind button, and then exit out to the main menu. Then what you want to do is power up your quad again. It might take a few seconds, but you should eventually see the flashing red light on the X4R turn green. Sometimes you have to move a little bit away from your quad for your radio to pick up the receiver.
Telemetry recovered.
Alright, there we go. The quad has picked up the radio, and you can see here that the light on the X4R is now solid green. And that's about it for the binding process. Pretty easy. So here's a close-up look of the bind button that I was talking about on the X4R. This should be the same process on the D4R2 as well. Alright, so now moving on to the FPV gear. To power the Hawkeye 200 milliwatt video transmitter, you can actually just solder the positive and negative directly to the flight control to the power distribution board, as long as you're running 3S. So just measure out the length of the wires that you're going to need depending on where you're mounting the VTX, and then cut the wires and solder them directly to the board. So I found the best location for the VTX is on the back of the quad underneath the rear plate. So as you can see here, I have the power coming straight off the board plugged into the power input on the Hawkeye 200 milliwatt. A great feature with the Hawkeye is that it comes with a pigtail already installed onto the Video TX. This way you can minimize the amount of connections between the antenna and the VTX, creating better reception. I was able to run the pigtail straight to the top plate of the Armattan quad, which actually has a hole that fits perfectly with the pigtail connection coming off the Video TX. For the antenna, I found circular polarized antennas on RCgroup classifieds made by Goonieworks. They're a really great price, and you can customize them to any color, size, and connection that you'd like. I was able to get a really short circular polarized antenna dipped in orange covering to keep with the orange theme of my quad, and I'm really happy with the results. For the FPV cam, I'm using the Aomway 600 CMOS camera. I mounted it on the front of the quad, underneath the top plate. First thing you want to do is take the cable coming off of the camera and measure out the length you're going to need to reach the VTX video in. Once you have it measured out, go ahead and cut the wire for the input to the VTX pretty short, and then snip the wire coming off the camera so you have enough slack to reach the other end of the cable going into the VTX. Go ahead and strip the outer coating of the wires, and then what we're going to do is solder these two cables together, in the end resulting in a shorter wire going from the camera to the VTX. Also note that there will be a bunch of loose wires when you take off the coating. These wires are actually the ground, so you're going to want a whole lot of those, and we're going to solder those together in the next clip here. Alright, so those loose wires that I mentioned are coming out of the camera. Those are the ground for the camera. Those are going to be soldered to the ground going into the VTX. At this point, gather up some small heat shrink, about 1 to 2 millimeters in diameter, so that we can protect each individual solder connection that we make. So all you're going to want to do is match up the color combinations coming from the camera and coming out of the VTX. And then also you're going to solder the loose wire coming off of the camera into the loose wire going into the VTX. So once you have all the wires soldered together, go ahead and slide up your heat shrink, and then either use a soldering iron or a lighter to tighten up the heat shrink to protect the connections. I also threw on some electric tape around the port coming out of the camera, as well as the heat shrink covering the connection between the camera and the VTX. As you can see here, I also zip tied the camera wire underneath the frame, and you can tell that it looks like we saved a lot of space with the wiring, and it looks like a really clean build so far. So I always use hot glue when mounting my cameras. It seems to work pretty well, and you can set the angle to any degree that you like. The nice thing about using hot glue is that you can set the angle to about 10 degrees to start if you're just learning to fly, and then gradually increase it as you learn to fly faster. To secure the power distribution board, I threaded through a 6mm nylon screw and then put an M3 hex nut in between the frame and the power distribution board. I then put the power distribution board onto the 6mm nylon screws poking through the frame, and then secured another nylon hex nut as a spacer, and then on top of that I put the 10mm male to female nylon standoffs, which we will then put the flight controller onto. Alright, so let's put the rear plate on to protect the video TX. I used 30mm standoffs for the rear. I had to use the 30mm in order to fit the pigtail antenna coming off the video TX to make it to the top plate where I mount the antenna. And then for the front, I used the 20mm nylon standoffs, which were just tall enough to cover the camera. So this is the standard top plate that comes with the Armattan, and you can see the two large holes are meant for the pigtail coming off of the video TX. This is a new plate that just came out. I haven't ordered it yet, but it looks interesting. So if you guys try it out, let me know how it works out for you. So these are the plates I'm using for the front and the back of the quad. They're pretty cheap. I think they're like $3 each. If you buy the full kit from Armattan, you'll get these included with the kit. Alright, so let's put the back plate on now. You can use the 6mm nylon screws. Just screw these directly into the 30mm nylon standoffs. And then what we're going to do is take the antennas coming off of the X4R and use zip ties and heat shrink to mount the antennas upright. So once you have the plates all mounted up, it should look something like this. I'm really stoked about this quad. I think it's like one of the best looking designs out there, and I'll definitely be flying this a lot more than my ZMR 250 moving forward. Okay, so I've got the zip ties on the rear plate now. Just make sure that they're upright, and then just slide the heat shrink over the antennas that should have come with your X4R, your D4R2. If it didn't, you can use multiple heat shrinks to fit the length of the antenna. Just use a lighter, just be careful, and tighten up the heat shrink, and then you should be good to go. So to tighten down the props, I recommend using the M5 lock nuts rather than the prop locks that come with the motors. These are a lot lighter and they're tightened down a lot better. So it's all ready to go. Let's do the maiden.